Next topic we are going to discuss is equipment safety measures. So, why we require equipment to be protected? So, whenever there is a short circuit occurs, a very high amount of current flows through the equipment. So, obviously, what all the equipments will be using, it will have some certain amount of rated current. If more current flows through that, obviously it will damage the equipments. That's why we require a safety measure should be taken. So to protect the equipments, we will be using mainly with respect to a fuse and the MCBs. So these two are the safety equipments what we are going to use. Then what do you mean by a fuse? So we know that we have heard the word fuse and the MCBs in our houses and day-to-day life. So fuse is an electric device that will self-destruct itself and stop the current to flow in a circuit whenever a high amount of current flows through the fuse. So whatever the fuse we want to take, it will have certain amount of current can flow through that particular fuse wire. If more current flows through that particular fuse wire, so obviously what happens, the fuse will get heated up and it will be melted and it will be broken. So that what happens, it will have an open circuit. So there will be an open circuit, the current will not flow through. So this is how your fuse will work. It will self-destruct itself and stop the current to flow through within that. So that's why while choosing a fuse, we should choose a proper rating, a current rating. If it is not being chosen properly, then the high amount of current will flow through the fuse and fuse will not be broken, right? At that time, the high amount of current will flow through the equipments and it will damage the equipments. That's why we should choose the fuse proper with the current rating. So to choose that one, we should have some desirable characteristics of a fusing element. So one will be a good conductivity. So whatever the fusing element we are going to choose, it should have a good conductivity. Next, a low melting point. So whenever the high current flows through that, so it should have a low melting point so that the fuse will self-destruct itself and stops the current to flow through this. Low cost. So it should be with a low cost. Then non-deterioration due to the oxidation. So due to the oxidation, it should not deteriorate. So this is how the fuse symbol is. So if you consider a circuit, so this is the circuit and this is the switch what we have, and this is the supply voltage, single phase supply 230 volt 50 hertz, and this is the load, and this represents the fuse. So whenever high current amount of current will flow through that, obviously what happens, the fuse will be melted and it gets open like this. So when it open like this, obviously there will be an open circuit, so it will stop the overcurrent to flow through this. So it works based on the thermal property of the material, conducting material. So it will consist of a metal wire or a conductor material which can conduct a predefined amount of current through it. So whatever the rating they have taken, it can only allow that amount of current to flow through this. Whenever the excess amount of current will flow through the fuse, the conducting material inside that will melt down and therefore the current through this will be interrupted. So this is how the fuse will work. So to look, so this is what the fuse will look like. So you would have seen this type of fuse near your energy meter. Usually this type of fuse will be installed near the energy meter, and these fuses are used in your equipments. So in the energy meter also, near the energy meter also will be using the fuses, and near the individual equipments also will be having the fuses to protect. So These are the types of fuses we will be using. So while discussing with respect to a fuse, we should know some terminologies. It is ratings of the fusing elements. So one will be the rated current. So then what do you mean by a rated current? So rated current is nothing but it is the maximum amount of the current which the fuse element can carry without any undue overheating or the melting. So rated current is nothing but without melting of the fuse. What is the maximum amount of current which can flow through the fuse? That is called as a rated current. Then second one will be the fusing current. A fusing current is the minimum value of the current which the fuse element can carry, right? Whenever the fusing current will flow through that, it is the minimum value of the current at which the fuse element will get melted and it will break the circuit. So from the definition we can make sure that your rated current should be always less than the fusing current. So you should know the difference. Rated current is nothing but it is the maximum amount of the current which the fusing element can carry without melting. But the fusing current, it is the minimum value of the current. If that amount of current flows through the fuse gets melted down. So next one will be the fusing factor. If you consider with the fusing factor, it is given by a fusing current by rated current. So fusing factor is nothing but the ratio of the fusing current by rated current. As we discussed, if a fusing current is always greater than the rated current, the ratio of your fusing factor should be always greater than 1. So usually the fuse elements what we are using, so those will be which will be made up of copper, zinc, lead, tin, aluminium, etc. These are all the materials by using which the fuse element is made up of. Then what are the merits and demerits of a fuse? If you consider with the merits, the fuse doesn't require any maintenance and is the cheapest type of a production. So whatever the fusing element we are going to get, it is a very cheap. You can get it at 10 rupees, 20 rupees like that. And it interrupts the enormous amount of short circuit current without any noise, flame or any gas. Whenever current flows through that, the fusing element gets melted up and it will break. So it will not make any noise or any smoke will not come like that. And it has current limiting effect and negligible replacement cost. So as I will discuss, it's the cheapest type of production. So to replace that one, it is a very less cost and easy removal for the replacement without any damage of coming in contact with the live part. So these are all the merits or the advantages of a fuse. Then what are the disadvantages? So whenever the fusing element melts, right, every time we need to replace with the new fuse element. And the breaking capacity of the fuses are very less. And whenever we will choose the current rating, right, it should be very accurate. So accurate calibration of fuse wire is impossible. So if you are not going to choose the fuse wire current rating properly, if the current rating is 5 amps and if you have chosen the fuse rating is 5 amps, whenever the maximum demand you want to use, at particular case the fuse will melt, again you should replace with a new fuse to get into operation. If you are going to choose the rating with 10 amps, example fusing is, but your loading capacity is only 5 amps, till the current flows 10 amps, the fuse will not melt. So but what all the equipments connected to in your house, is the rating will be 5 amps. So it might damage your equipments. That's why the accurate calibration of the fuse wire is little bit difficult. These are the disadvantages of the fuses. So then where they are going to use? So in domestic purpose we are going to use near the energy meter, and in all the equipments it will be there. Apart from that, so we're going to employ these things in the domestic installations, a motor installation. So we can use all this fusing